We've been doing demonstrations with our end users, with our dealers over the last few months. And one of the things that's really surprising when these operators get into the machine and start operating it is the performance itself. Because some operators kind of understand from the automotive side that there's a lot of power out there. But other operators are thinking, well, wait, this electric product's just not going to perform as well. So they're surprised in a good way that it does perform. And that's for sure. The second thing that they're surprised about is we had one crew that was operating and they're actually talking with each other as the person was digging a trench. And then it dawned on them and the light went off. Wow, we can talk while we're operating here. I don't have to put it down to idle.
Good afternoon. Greg Schultz here with Charged. We're going to talk about electrification in off-highway equipment. And to that end, I'm joined today by Brad Stemper, Brady Lewis, and George McIntyre from Case. Gentlemen, if you would please just go ahead and introduce yourselves, what you do in the company.
Great. My name is Brad Stemper, North American Product Management Lead for the construction segment, Case Construction. Been with the company for 25 years, in the industry for over 25 years. Have had a variety of roles, and I really appreciate the time to speak with Charged and share some of our insights on electric powered equipment.
Yeah, I'm Brady Lewis. I'm the North America Product Manager for Emerging Products and Technology. And what that really means is I work a lot with our electric vehicle portfolio, and really excited to kind of talk through the trends that we're seeing in the off-highway space with you and your listeners.
I'm George McIntyre. I'm the product manager for the Backhoe loaders for Case. I handle not only the electrified 580 EV product, but also the diesel-powered models as well.
Excellent. Well, thank you guys very much for joining me today on a Friday. We really appreciate you taking out the time to do that.
Sure thing.
And talking about one of our favorite subjects, which is kind of the advancements in the off-highway space as it relates to electrification. So with that in mind, we'll kind of jump right into it. So the way this all came about is we had gotten a product announcement from I think it was your PR company, mentioning that you were releasing a new electric backhoe, and that's definitely right in our wheelhouse. That caught our attention right away. So we reached out to see if you'd be interested in having a longer conversation about that and kind of how it came to be. So maybe from that angle, if you wouldn't mind telling us, was this project driven more by market demands, trends you're seeing in the industry? Was it driven by kind of regulations, all of the above? Maybe give us a little bit of insight on how that got started.
Sure. I can go ahead and start it, and if Brady and George want to add in, we'll let them do that. So Case has always been a leader within the backhoe loader industry in North America, and having been the first to factory integrate a backhoe onto a tractor loader back in 1957, we've always kind of felt like we've been the brand or one of the top brands in the industry, kind of pioneering what is a backhoe loader, the features, the equipment, the models, and so on that go along with it. And so when we look at, as a company, we look at alternative propulsion or alternative fuels, we often consider the primary product lines that we put out. Electrification itself is very conducive to the types of backhoe customers that use the machines, whether that be municipalities or utilities that have a high stake in using the machines to go out and do day jobs or a variety of projects on those applications. We saw electrification as being particularly beneficial to the product line. The duty load, the application need, the time of work actually on the job site is very supportive of being driven by an electric powertrain or a battery operated machine. And so we looked at that opportunity and we started progressing down that path. It really helped when we had two key customers out on the East Coast, large energy companies, reach out to us and simply say, we're interested in trying to progress our sustainability efforts. And so we partnered with them. We partnered with another battery company. We kind of drove Project Zeus, which was the concept machine launched or displayed at ConExpo 2020. And that kind of set the stage and started this whole ball rolling down the street. So
was that kind of like fortuitous timing, or were you already working on the project and they just happened to mention it, or were you in constant communication with them already and they had mentioned it was something they were interested in, so you started going down that road?
We had started seeing the trends, right? We saw the application of electric vehicles and the interest by the general public, brands like Tesla and others kind of ramping up their efforts and all the focus on it, battery production coming stateside and things like that. So we had already started exploring the opportunity. And when these two brands or these two companies came to us, we kind of recognized it and said, well, this is the launching pad, right? This is driving more than just the investigation or the kind of high level discussion around it. And so that kind of really put us into it.
Yep. And to add on to what Brad is just saying, they actually put up some of their own money, some of their own R&D budget to help us with it. So that told us a lot that they were willing to actually invest dollars into it.
So you mentioned that, you felt that electrification was a good use case for this type of equipment. So maybe you can dive a little deeper into that in terms of, the thing that got us started on this conversation was the 580 EVs. Mm-hmm. So how does that performance compare to the diesel models that I would imagine were there previously, especially in the challenging environments like construction sites?
From a performance standpoint, it would be very similar to the performance that we have on our 580 Super N model, which is our most popular model or our highest volume backhoe model that we have out there. And we chose that model to kind of be the benchmark because it's kind of in the middle of our range. So it's not like our bigger units, which would draw a little bit more energy and you get less battery life, and it's not on our small end either. So it just made sense to use that model. I'd like to share something real quick, though. We've been doing demonstrations with our end users, with our dealers over the last few months. And one of the things that's really surprising when these operators get into the machine and start operating it is the performance itself. Because some operators kind of understand from the automotive side that there's a lot of power out there. You have instantaneous torque when you actually go to, say, push the accelerator or to operate the controls. But other operators are thinking, well, wait, this electric product's just not going to perform as well. So they're surprised in a good way that it does perform, and that's for sure. The second thing that they're surprised about is we had one crew that was operating, and they're actually talking with each other as the person was digging a trench. And then it dawned on them, and the light went off. Wow, we can talk while we're operating here. I don't have to put it down to idle. So that is the second thing, is that the noise piece of it. They love how they're able to communicate with those workers that are on the ground easily from inside the cab. Yeah,
this is definitely a theme that we've heard before during these conversations. Mm-hmm. Is they're surprised by that. They're always caught off guard by how quiet it is, and then there are always some features that maybe they weren't expecting that seem to work well. And another theme that we've heard a lot, and maybe you can speak to this a little bit, is there's still range anxiety with some customers where they're worried. They'll look at the rating of the battery and say, oh, it can get me, let's just say for the sake of argument, 6 hours of use. And they're like, well, my day is 8, so that doesn't work. But they don't realize that it's only when the machine is actually operating that they're eating into that battery life, where there's a whole lot of idle time during the day in some of these cases, where before, maybe due to environmental conditions, maybe it's cold outside, maybe it's really hot and they've got to run air conditioning or they got to run the heat, that they have the engine in idle during those hours, where that's not really a thing with the electrified equipment. Is that something that you've also heard?
Absolutely. For sure, particularly when we're talking about the backhoe. The backhoe is no longer a production machine like it was 20, 30 years ago, where people are using it to dig foundations or swimming pools. It's more of a support piece nowadays. And we know from telematics data that it's 30 to 50% of the time it's idling or completely shut down even. And if you look at, Brad had mentioned municipalities, which is one of the key customers for this. I mean, you look at their usage and they will go out and do a repair. Say it's a water main break. They'll go out there. They need to bust up the concrete or asphalt with the hammer. They need to dig down to get down to that water main break. Then there's some downtime as they fix it, and then they'll put the spoils back into the hole, and then finish the repair off. But there's a lot of downtime during that whole process. So that's just one example. But absolutely, yeah, we take that into account when we're looking at the longevity of the machine during the day as well.
Yeah. So as you were doing this project, I'm sure you entered into it with some ideas of what the benefits would be, maybe what some trade-offs were. Was there anything that kind of surprised you that as you got down the road with the project, you were thinking, wow, it's going to function even better than we thought, or were there any hurdles you ran into that maybe you weren't anticipating?
I can say, as being one of the people that were able to jump on the first production or the first prototype that we built, I was really amazed at how much, and George kind of mentioned it, the instantaneous torque or the instantaneous power behind it. There was no power drop off. And it was the fact of, you step on the accelerator pedal like you always had with a diesel machine. And now you literally did a little bit of a wheelie because the tires just grabbed and took off. It wasn't a stock car or a drag car or anything like that, but it was definitely different than what you had ever remembered. And that instantaneous response to whatever the control input was something that we really learned a lot from. And I would say, the actual product could have made the market much more quickly, but we spent a lot of time tuning and retuning, trying to drive efficiency into the battery utilization, right? Trying to pull any extra battery life out of it, simply because you don't need to pull the trigger, step on the gas pedal, or pull the joysticks like you would have in the old machine, right? There's no ramp up, there's no engine throttle and trying to find its optimum torque curve or anything like that. When you start moving the whatever it is that is normally commanding the machine to move, as soon as you start that, you've got response. And that was interesting. That was a lot to learn and a lot to understand, but also created a whole new way to think about how to make this machine do the work that the diesel machine would.
Yeah, I think, Brad, you kind of hit on where I was going, thinking about was that tuning piece of it, and not just the controls in the field, how it accelerates when you push the accelerator, but also just the energy management, right? So the EV, of course, is a very sensitive to the application that you're doing and how you're using the machine and what does that translate into runtime. And to me, it's been very surprising, and then, kind of pleasantly surprising, now that we're at the end of the process, is that the very first prototypes that Brad was talking about that we worked with those two key customers on, the amount of runtime that they were able to get out of a battery charge to where the machine is now is dialing in that system, dialing that tuning, understanding what the energy is doing. And when I'm digging, in this type of soil conditions, what does that do to my energy levels? And I think it's just something that we're going to learn, in the industry as more electric vehicles get out there, because honestly, in a backhoe, you put fuel in it and you don't really pay attention, throughout the job day of how much fuel you're consuming. You just know when it's empty, I'll fill it back up. And so on the EV, you're much have better visibility to that energy consumption and understanding how you're using the machine, and we're able to tune that as an OEM and make the machine perform better. But also operators themselves, they're kind of tuning their own experience. We also have other EV products, and I can think of a story of we've had some of our mini excavators out with a customer, and same customer, same job. They were basically putting in water lines in a subdivision. And so it was literally the same job for a week straight. They'd do, 2 houses a day, and then they'd move down to the next 2 houses. And over the course of that week, the operator got better and better and better at using the machine efficiently. And the amount of battery or energy he had left at the end of the day increased throughout the whole week, because it's that operator learning how the machine operates and kind of optimizing based on the energy consumption. So that's been very interesting to me, is how that all plays into the real world.
Yeah, definitely. So, okay, so we started talking about the technology and performance and maybe some things that the users really loved or what they were expecting and what they weren't. That's definitely an important angle of it. Another angle, though, that a lot of people are somewhat becoming familiar with as it relates to EVs is maintenance costs and savings. So on that end, what are some specific long-term maintenance savings that this kind of or that people utilizing this kind of equipment can expect with any of the electric machines that you're working with?
There's the obvious. I mean, you no longer have the engine in there, so you lose the diesel engine. You lose all the filters that you'd have associated with that, whether it be the engine oil filter or the fuel filters and those sorts of things. And actually, one of the things we did when we had Project Zeus first introduced back at 2020 was at ConExpo in Las Vegas. We actually had a bin there that we took all these components that were going away with the 580 EV, and we kind of put it inside a bin so everyone that was there at the show could see what components kind of go away. And it was kind of filled to the brim at that point. So there are a lot of things that are not there, but there are still maintenance items that you would see on a regular diesel powered unit. For example, your hydraulic filters, we still have hydraulic oil in there. We're still using a traditional transmission in this particular version that we have now. So there are still some maintenance items that are out there. We've looked at what the savings are, and we estimate they're between 40 and 60% savings for the 580 EV on the maintenance end of things versus the diesel powered. But with that, one of the things we want to know is we want to know what the customers are experiencing, and we want them to bring it back to the dealer. So we have an EV care program out there that covers it for the life of the warranty, which is 3 years, 3,000 hours. EV care for the 580 EV, what it does is it gives those customers a peace of mind that our dealers are going to actually do the maintenance on those units through those 3 years at all the main service intervals.
I'll add one more point onto that regarding the maintenance and cost savings over the life of the machine. We already mentioned how customers have in mind that range anxiety of, I take the machine out and I'm gone 8 to 10 hours that whole day. I need it to run 8 to 10 hours. And the brand who's telling me about this EV machine says it gets 6 to 8. That's too short. We already discussed how it's operating less. Well, with that reduced operation and with the machine only truly running while you're pulling the trigger or grabbing the handles, right, you're actually putting fewer total hours on the machine each year. You're not accumulating 6 or 7 or 800 hours. You're actually accumulating 40, 50, 60, 70% of that total because of how much idling that old diesel machine or that diesel machine would have done in the past. So you are still doing the same maintenance on those other components, like George was saying, the hydraulics, the transmission, things like that, but you're doing them less frequently because the machine is not accumulating as many hours in a year or in a 2-year, 3-year period like it had been. So you have the scale of not doing certain work and doing the remaining work less often. So it really adds up.
So okay, as we move into fleet integration, how do you ensure compatibility between existing diesel fleets and new electric machines in terms of operational logistics, training, et cetera?
I'll talk to it directly from a 580 EV standpoint. So for the Backhoe, one of the things we looked at as we're bringing this new Backhoe on board, first of all, in a lot of ways, it's a ground up machine because there's a lot of new systems here. But when it came to the operator interfaces, we wanted to keep that as much as possible the same as what we have on our diesel powered units. So something as simple as like turning the controls on for the Backhoe operation, we kept those switches actually in the towers for the what would have been the pile control handles. Now it's fully electro-hydraulic, instead of putting it into the touchscreen display that we now have in the 580 EV. So we purposely tried to keep it as much as possible the same between the two. So an operator goes from a 580 Supra or a 590, they jump into the 580 EV, it won't be completely alien to them and different to them, right? So that was one of the things we were looking at to make sure that we kind of keep it consistent. On the other side of things, with this new electro-hydraulic product line, with the 580 EV, it gives us some things that we can actually add to the diesel-powered models in the future. Like we've added factory-installed 4-corner multicolored strobe lights. That's something we plan to bring down onto the other models as well as into our wheel loaders and some other product lines.
That's interesting how the evolution of the EV product is actually helping to even make the diesel lineup
Correct.
stronger.
Yep.
That's really neat.
Yeah. The other thing George talking about the backhoe, and it's that same philosophy carries over on our other products. So our mini excavators and our wheel loaders, it's trying to make that operator station look, feel, all the buttons are in the same place so that a customer can, jump from one machine to the other. Because like I think George mentioned, we expect, a lot of our customers, they're going to have a mixed fleet of diesel and EV machines for, a long period of time. So having that consistency across the product, I think is going to help. One thing I guess is not exactly your question, but I think it's worth talking about, operators is one thing that we've heard and seen from customers using the machine is even though all the buttons are the same place and that switch is exactly the same place I expect it, there is some amount of transition. So we've done everything we can to set up the machine to run the same, but at a fundamental level, and a lot of it has to go back to kind of auditory response. So operators that run the machine are used to you listening to the sound of their diesel engine telling them how the machine is performing, right? So they know they're really putting it to the hydraulics when they hear that engine lug down. And now on the EV, you don't have that noise. And so we've certainly had lots of conversations with customers that there's other clues on EV because you can hear the hydraulics, a little more clearly because you don't have an engine there, running. But it is kind of interesting that at some level you've set everything up to be as similar as you can, but there is a little bit of operator kind of learning again how to maximize the performance of the machine because there's, aspects of a diesel machine that we've all just taken for granted, whether it's the vibration or the noise level of, the engine lugging down. So it's been really interesting listening to operators after they run the machine of how they're kind of adapting to the EV because there are those fundamental differences between them.
So where you see those differences, do you find it's like a pretty steep learning curve, or do they adjust to it fairly quickly?
Generally, it's pretty easy, and I would say that a lot of the people that are really picking up on this are your more skilled operators, right? So these are guys that have been running a backhoe for 20, 30 years, and so for them to pick up on the nuances and adapt, they're a couple hours into it and they've kind of gotten used to it. You're less experienced. When I get on the machine, I know how to drive it, but I would never tell anybody that I'm an operator. When I'm on it, I'm probably not even listening to the engine lug down, right? So it's those guys that have really put in the seat time, but because of that, they're pretty easy to pick it up as they go because they've got all that experience.
We kind of reiterate a phrase in our marketing and our materials about just another tool in the toolbox. We want people to understand that the integration of EV or these zero emission machines is not just the application of a specific machine that customers need to migrate to entirely. It's an aspect. Consider it a long arm or a short arm, right? A track machine versus a rubber tire skid steer. It's what they tend to employ for specific applications. So EV might literally be some of the product within their fleet, and they might have the diesel equivalent backhoe or loader or mini excavator sitting next to it, simply because different jobs dictate different needs, right? And they might have the need to work much longer on a given job or refuel it much more quickly on a given job. So they'll employ the diesel, or they're working inside and they can literally run that mini excavator or backhoe inside a closed environment where they would have exhaust situations and needs to manage. So it really is simply something we've tried to identify to our dealers and customers as this isn't a change in philosophy. It's an evolution to the product offering.
Well said. So, okay, as we get out onto the construction site, moving from just adopting these into your fleet, but once you have them in your fleet, we've spoken a little bit about people's concerns with, basically battery life. If they are out on a job site, what advancements in charging technologies or partnerships are in place at the moment to support the adoption of the EV equipment that's already there and a more widespread adoption of EV equipment on the job site?
We've definitely seen charging as one of the obstacles or questions that customers come to with when you talk to them about an EV machine as well. How am I going to charge the thing, and how's that going to work? And I know that you are familiar with the obstacles we've seen in the automotive space, a lot of those processes, the identify what's hampering EV adoption in the automotive world is charging infrastructure, and part of it, like you said, is range anxiety, and so some of it, is maybe a little bit in people's head, but some of it's practical, where and how am I going to charge a machine? So we've seen that, and the primary way that we're approaching it is we are designing the backhoe to take advantage of the advancement in the automotive world, right? So there's, every automaker is spending, billions of dollars, and there's all this ecosystem of companies creating innovative charging solutions, and whether it's a battery pack on wheels that's on a trailer that you can take around to charge up your machine, or whether it's a kind of a solar panel that's got an EVSE sitting at the bottom of it that charges through the day, and then you charge your machine at night. So there's lots of innovation going on, and our approach is to try to keep our machine as close to the automotive standard as we can. So we use a standard level 2 J1772 connector, just like most automakers, are basically everybody but Tesla. So that's, I think, reassuring to customers, especially you talk to a municipal fleet manager that has a fleet of Chevy Bolts or F-150 Lightnings in their yard, and to be able to say, oh yeah, look, here's the backhoe takes the exact same port. All that infrastructure investment that you've made carries over onto this machine. Oh, okay, that makes more sense. And so, even to the point of backhoes are used in some urban applications. There's probably a few customers that may have a need. They can go to a commercial charging station to plug in. I think level 2 charging stations are pretty popular. And actually, George and I were on a customer event in Texas, and we decided that we're over at some shopping center, and we finished up with the customers, and they all went home, and we literally drove the backhoe through this like strip mall in suburban Dallas, and was trying out different charging stations to say, oh, does it work? Does it work? Okay, good. And then we might drive to the next one. So that is something that most customers that we're selling the 580 EV to, most of them have a yard that they're parking the machine at night and they're doing the charging. But having that knowledge of, I can go to this charge point station at the bicycle shop, gives them some comfort, right? That they know that they have those options. There's also there's more development going on. Case, as you well are aware, is part of a larger company. So we're sister companies. We have an agricultural brand and another couple pieces of company, and so that's an area where charging is such a fundamental thing that our peers that are working on electric tractors are facing the same challenges. And so we're definitely working on development and future projects with them. But right now we don't have anything public to talk about. But the key thing is that by sticking with those automotive standards, we're able to kind of continue on, and following through with the advancements in the automotive space will carry over to the off-highway world. When I'm talking to a customer, the joke I like to tell people is that when they figure out the charging of all the people that are going to go to the Burning Man festival, then we will have the construction site figured out completely.
I like that. So do you find, since you mentioned the kind of commercially available charging solutions that are out there, when you tell them that, do they kind of nod along and they say, oh yeah, that's a good point, I could just drive over to the BP and charge my equipment? Or are they, in a real world use case, is it going to be a better solution for them to have more of that portable charging solution that they can just bring to the job site and say, okay, the backhoe is getting low, plug it into the battery pack, get it charged up?
Right. I think for most customers, it's the second one. It's having some energy solution that can deliver power to the job site. That's going to be the preferred. The ability to kind of go to that commercial station is kind of as last resort. Jim Bob wasn't watching the meter and he ignored all the alarms that went off, and he's now down to 2% battery. What are we going to do? And so I think for most customers, they want to control their own destiny, and they want to know that if Jim Bob leaves the machine on too long, or doesn't pay attention to the alarms, that okay, we'll dispatch the truck that's pulling the battery pack. And it's not necessarily the most environmentally friendly, but customers are aware, and they have an option. You can charge the machine off of a generator if you have to. I mean, if you're really at the point where you're not able to get the machine and it needs just a little bit of extra juice to get back on the trailer and get back to the yard, that is an option for them. And so that's kind of basing on their level of comfort of being able to kind of control their own destiny.
Yeah, and I think that's really, at the end of the day, sort of a great takeaway for them is you have a lot of options. We're not telling you you have to just charge it back at the lot, or you can only charge it at these commercial charge points. Like, you have a number of options, and that's going to give you the flexibility that you need to feel comfortable utilizing this equipment in the field.
Exactly, yeah, and that's a lot of the conversations we have with customers. Is once we kind of explain to them and they get to go operate and see the performance of the machine. All right, box check, the machine can do the job that I have. Then it's this conversation about energy management, right? Is how does your application work? How are you using the machine? A lot of the customers that municipal customers, they actually road their backhoes. That's why they use a backhoe, is because it can self-deploy itself out to the water main break and drive across town and go do it. And so understanding, where's your yard and how big of a radius are you trying to drive, and all those kind of characteristics go into it. But it's all thinking about the energy. And normal situation, you've got this amount of energy, you can drive this far, you can dig this long. How does that fit for your normal application? If something happens and you need to charge the machine at the job site, here's some options to do it. And exactly like you said, it's giving those options and seeing how that fits best for the customer and their application.
So moving forward, kind of bigger picture sustainability goals. So how do the electric machines align with global sustainability goals, regulatory frameworks, especially as we're talking about emissions reductions and noise pollution?
Sustainability goals for CNH, which is Case Construction's parent company. CNH kind of stands for Case New Holland. The merger happened back in 2000 timeframe. So we've been part of CNH, and CNH is actually one of the leading manufacturers on the Sustainability Global Index for companies. And so we do a lot, CNH as a whole, we do a lot with, alternative power, alternative ways to control that power on the machines, sustainability through our plants and carbon footprint and things like that. So it's a core value within our company to drive that sustainability effort and improve sustainability measures within what we do and how we do it and what products we offer. So when we look at this, the EV products are just a piece of what CNH puts out. At the same Con Expo that we launched Project Zeus, which was the electric backhoe concept, we also had a methane wheel loader concept. Our ag brothers and sisters have put out different alternative fuel machines for the ag industry and things like that. So we try to incorporate a lot of that into what we do. And we've kind of mentioned the 5 different product lines, or the families of products: mini excavators, backhoe loader, and small articulated loaders, as being kind of the core of what we're offering. We look at those machines contributing on a state or national level. We have those similar products being launched or already launched in other regions. So we see that affecting their business and operations. And we see those sustainability targets really being localized right now. There's specific municipalities or states or government entities that are really driving sustainability at different levels. But I'll take it one step further and say, we mentioned the term evolution, or the phrase a tool in our toolbox already. And within those mindsets, we see our investment in EV not just contributing to our EV product, but advancing the greater product line offering as a whole. There, like George said, we're migrating technologies that we put into the 580 EV into the diesel backhoes. We're migrating those philosophies or those new understandings about applying electric power into different systems for the future. Right now, North America is governed by emissions regulation Tier 4 final, right? Europe is governed by Stage 5, which is one layer a little bit higher than Tier 4. We're already talking about Tier 5 coming in 5, 6, 7 years. So I can guarantee that the insights and the knowledge aspects that we're gaining on today's EV machine will continue to evolve, and they'll contribute to more efficient power use, power generation, application of machines in these later years for regulatory needs, for noise abatement, right, and quieting the job site down, improving the quality of life, not only through emissions, but noise pollution and things like that. So it's really one of those aspects when we talk about sustainability goals. It is the evolution of the machine and really putting in a methodology and a conceptual practice to what we do on a daily basis to grow sustainability as a product offering. And that will migrate into so many different things that we do. And that is kind of where we look at it as from CNH's point of view and Case Construction's point of view. That's where we approach it as this is a betterment of the product offering and the people who use it and their lives. So it's kind of how we approach it.
Gents, anything else that you wanted to say on that?
I think Brad covered it pretty well. I was going to throw in some comments about noise, but then you got me right at the end. So
yeah, it definitely makes quite a difference. We've noticed it. So off subject, but we just picked up a hybrid minivan, and it weirds my wife out when she's backing out of the driveway. She's like, "Is it on? I can't tell if it's going yet."
Right.
So it is definitely a game changer from a noise perspective. So at any rate, taking us back to the subject. So a lot of our audience are engineers, right? So they're working on these challenges. So maybe you can tell us a little bit about some of the development challenges that you faced in Project Zeus. Maybe what were the most significant technical challenges that you encountered developing the 580 EV and any of your other electric models?
Yeah, I can start off. I can talk a little bit about Project Zeus. And I think with that project, I would like to say that, you're talking about challenges, but because of our approach, we weren't really looking at it as challenges. The nice thing is we did, put the money into this, an investment to make sure we did it from the ground up and we did it the right way. So it wasn't the approach of, we're going to take one of our diesel-powered models, we're going to remove the engine, put the batteries in there and electric motors type of thing. So we were looking at a little bit more with a clean sheet of paper, which allowed us to overcome some of those potential challenges that you might have had if you went the other approach. So in terms of those types of things, it really comes down to space and layout, a lot of it, where we need to put the components, what's the best place to have them. I'll use an example of the batteries themselves. So the spacing, because of the size of the batteries, is different than what it was for the diesel engine. So what that drove was a change to the hood design itself. Okay, so there's a very simple example of something that we changed based on the electric versus the diesel. Also, the battery management system. What size tank do we need to put those components in? And we put those where the steps on the right-hand side of the machine are. So we had to look at the steps and on both sides actually, and where the components are. And we actually switched the hydraulic tank on the diesel-powered units is on the right side of the machines. On the electric-powered unit, the 580 EV, it's on the left side. So we actually switched sides of that. And where with the diesel tank not needing to be there, that's where we put the battery management system components. Okay, so those were the types of things we were looking at as we were designing this. So I wouldn't really look at it as challenges. We just made sure that we took the right approach from the beginning, and that's how we got where we're at now.
Yeah, I didn't mention it when I did my intro, but my background before this role was on our skid steer platform, which obviously is a small machine. And I would have told you, a backhoe, it's huge. It's got lots of room, compared to a skid steer. But you start going in, and like George was saying, you look at how you're going to package all these components, or you look at, like our traction motor is a pretty powerful motor. It's, big. It's a large component. You got to figure out where you're going to place this thing. So there's a lot of work I think that the engineering team did, making everything fit, making it kind of packaging into a logical manner. And then also, as George said, it's a ground up redesign of the machine, but you're also trying to take advantage where you can of components that we know the history. We know we've got, a history with this loader arm weldment structure, type of thing. And so taking advantage of all of Case's 60 years of building backhoes to know that, let's focus our energy on the new side, this high voltage side, and let's make sure we're carrying over as much of the components that make sense from the diesel, because we know that they have the quality and the reliability out in the field.
Yeah, and so you had mentioned, or a few times during this conversation, we've talked about the hydraulic system. Was there any consideration, or did you kind of weigh out the pros and cons of sticking with a hydraulic system versus electric actuation?
Yeah, and that's actually a question we get occasionally. People there's concepts out there that are using linear actuators instead of a hydraulic cylinder. And for us, it was just kind of that balance of two things. Is first of all was the practicality of how customers are going to use the machine. So we do have still a significant number of customers that are trying to run hydraulically powered attachments. And so they're using a broom or a compactor or a hydraulic breaker on the machine. So that obviously is much easier accomplished if you have a hydraulic system on your machine. And then the other piece of it is, like I was saying on George's question, is kind of balancing from an engineering standpoint, technical risk of how much of this exercise do you want to, how big of a bite of this elephant do you want to take. And so we felt like it was, from a development standpoint, and that kind of leads into, the quality of the final product, is that we have enough new things going on integrating a high voltage system into the vehicle. Let's not add changing to the locomotion of the machine onto our plate as we're trying to get this. And so I think that there's still work to be done on electric actuators. It certainly makes sense from a energy management standpoint, and I think that the future is going to take us that direction. But for our application, we were trying to focus on what is going to be the most impactful for our customers practically out in the field today. And so for the way we kind of weighed those was that, well, let's focus our energies on the high voltage side, and let's stick with what we know in the hydraulic world, because little less technical risk there, and also kind of helps that attachment situation for the customers that are using it.
Absolutely. This has been great. We've got one last question to touch on here, which is, we no conversation surrounding electric vehicles would be complete without discussing battery technology. So maybe take us into your world a little bit. How do you plan to innovate around battery technology to further increase machine runtime, reduce charging times, things like that?
I think that's definitely an area where we're going to see advancement. And actually, I probably should read some more articles from your company as far as, what's the state of the art out there. It seems like I'm always seeing, an article about some, research project is now, quadrupled the amount of energy density, or they've reduced charging times by this, or they have so many thousands of cycles on this type of battery. And so for Case, we're really focused on that practical application in the off-highway space. And so I'll be honest, when you get to the details of battery chemistry and the laboratory science that goes into developing all of that, really our approach is automotive is going to spend a whole lot more money and a lot of time and effort developing those things than we could do on our own, right? We just don't have the scale that a major OEM in the automotive world has. So our approach is kind of keep our machines up to date, that as those developments are happening in the automotive space, as every car company is trying to compete on range or decreasing their charging times, that we can kind of adopt those and keep those going. But we don't really see a lot of place for Case to be having a battery scientist in a lab, coming up with brand new chemistries or something like that. And so our whole approach is kind of see where automotive takes us. You've seen, and I know you probably know this better than I do, as far as the cost curves, over the past 20 years, or the energy density curves over the past 20 years. There's lots of people and advancement going on, and our approach is, make sure our machine is just kind of capable of taking those advantages and slotting them in and continuing on the next generation.
Yeah, and I would not be doing my job for our organization if I didn't plug our virtual conference series, where you could learn a lot more about that and many other things in the electric vehicle world. Sorry, I had to. You set me up. Yeah, very good point, though. I mean, there are a lot of advancements going on there, and there are a million different approaches. Some could wait and see where it takes you. There may be others who are going to look at making their own advancements in the battery world that are maybe specific to a use case. There's certainly a lot of change going on there. There's a lot of excitement, and we've already seen that range has increased, charging times are decreasing. That's only going to continue. So yeah, definitely makes sense.
I agree. I think there's a lot of analogy to, to go back to diesel engines a little bit, that, there's on-highway diesel engines and then there's off-highway diesel engines. And this has been years ago when I first started, that we have a case engine that was, I think it was tier 2 days. So it's been a while, but it was essentially the same engine block and technology as a Cummins engine in a pickup. And so we were able to use this, Cummins developed their, pickup engine that's in a Ram pickup, and then your case dozer had the exact same engine. It was a lot less horsepower because it's kind of built around this industrial block. But you have the technology leading in the automotive space, and then the off-highway wasn't exactly just, copy and paste. It was kind of an industrial version that was built for the vibration, the duty cycle of an off-highway application, but it's using that technology to advance the off-highway world, because the on-highway guys have so much more volume and scale than what we do.
Absolutely. Yeah. And I mean, you see that across use cases, right? Like there would be, in some cases, the same engine that was in a combine would also be in a giant ship. So yeah, there's a lot of opportunities to take advantage of advancements that have already been made in other sectors, for sure. Well, gentlemen, thank you very much. This has been a great conversation. I hope you'll be open to joining us again on another episode. Hopefully our audience has gotten a lot out of it. I certainly have. And we definitely appreciate your time and your willingness to join us. So thank you very much.
Thank you.
Awesome. Thank you.
All right. Well, given that, we will sign off for today. Make sure to check us out the next time on the Off-Highway Electrification series, and have a good one. Thank you.